Alright, so this is continued from Friday. We already talked about g of x being the sine, 7, the sine of theta minus theta. So we have 3 more examples to do, and then we're going to call it quits in terms of notes for this section. I have a couple more assignments for you guys to work on. So h of x is equal to 3x plus 4 quantity squared. What I would like you to do in this case is just remember that 3x plus 4 squared really means 3x plus 4 times 3x plus 4, which is equal to, remember that you need to FOIL this. So when you FOIL 3x plus 4 times 3x plus 4, you have 3x times 3x, which is 9x squared. And then you have 3x times 4, which is 12x. Then you have 4 times 3x, which is 12x. And then you have 4 times 4, which is 16. So the derivative of this then is going to be not that bad. The derivative, oh, by the way, I should clean this up a little bit. 12x and 12x, of course, give you 24x. So what is the derivative of 9x squared? 9x squared is, you multiply 2 times 9, you get 18. X squared, you take away 1 from the squared, you get 18x to the power of 1. And then 24x, what's the derivative of 24x? It's just going to be 24. So you have a plus 24, and then the derivative of 16 is 0. So I don't even bother adding the 0 at the end. So the derivative of 3x plus 4 squared is 18x plus 24. All right. F of x equals x to the 2/5 power minus x to the 1/3 power. So 2/5 power, already a fractional exponent. There's no cubes and square roots or whatever the case is. So we're going to go with this. So the derivative of f of x is going to be equal to, remember you take this power 2/5 and you multiply it by the coefficient in front of x. So you get 2/5 x, you subtract 1, so you have 2/5 minus 1. Negative 3/5, so you're going to have negative to the negative 3/5 power. We'll clean that up in just a minute. We're going to move on to this thing now. We have 1/3. That has to be multiplied by the negative 1 in front of x. So we're going to have negative 1/3 x to the, and you take that 1/3 power and you subtract 1 from it. You get negative 2/3. All right, we have negative exponents, weird, awkward, don't leave them like that. So this 2/5 x to the negative 3/5 power really is 2 over 5. That x goes to the bottom, but what happens to the negative 3/5? Becomes a positive 3/5. So we have 2 over 5x to the 3/5 power.
Do you put it in the square root thing?
We'll go there in just a minute, okay? Minus, we have a 1 on the top, over, on the bottom we have a 3, and we need to move this x to the negative 2/3 to the bottom. So we're going to have negative 3x to the 2/3 power. Alright, so this would be a sufficient answer, but let's take it one step further because you guys could use practice changing things from fractional form to radical form. So we have 2 over 5. We have x to the 3/5 power. Well, that 5 on the bottom means that is our root. So we're taking the 5th root of x to the what power? To the 3rd power. Yes. Minus 1 over 3. The denominator 3 means the cubed root of x to the power of 2. So either one of those answers. g of x, let's clean this up. The fourth root of x squared. Well, that means 4 over x to the what exponent? 2/4. Very good. Well, what is 2/4? Okay. So this really is 4 over x to the 1/2 power. But I can't do anything with this yet because it's a fraction. We need to make it not a fraction. So what we're going to do is make this 4x to the -1/2 power. So this 4 over the fourth root of x squared really means 4x to the -1/2 power. A lot of work to get there, but that's what it means. So now the derivative of g of x is equal to, you're going to take -1/2 times 4. What's -1/2 times 4? -2. X to the, alright, so we have a -1/2 power. We need to subtract 1 from it. What is -1/2 minus 1? -3/2. Yep. Got to get rid of that negative exponent. So that is actually equal to -2 on top, and on the bottom is where we move this x to the -3/2 power. So it becomes -2 over x to the 3/2 power, positive 3/2 power. Which you could also write as -2, very good, over the square root of x